Welcome to this explainer. Today, we're looking at some of the most mind-bending, honestly, almost comical extremes found anywhere in the known universe. We're talking about the extreme physics of neutron stars. If you think you know what heavy, fast, or strong actually means, well, I promise you, the universe is about to redefine those words for you entirely. We're going to completely dismantle your understanding of normal physics and venture right into a realm where the laws of nature are pushed to their absolute breaking point.
Okay, let's dive into this. I want you to really imagine the dramatic cosmic death of a massive star. Picture the sheer, unbelievable scale of a stellar giant reaching the very end of its incredibly long life. We're talking about a star that's been burning furiously for millions of years. So what actually happens when a star like that simply gives up, runs out of fuel, and collapses in on itself? It's a fascinating question, and the answer actually sets the stage for one of the most bizarre transformations in space. It's a total cataclysmic event that fundamentally reshapes the very fabric of the star.
Section 1. The collapse of a massive star.
You see, this violent, explosive collapse doesn't just leave behind an empty void or some random cloud of space dust. The destruction is spectacular for sure, but it's the aftermath that's truly fascinating. When a massive star collapses, it can actually leave behind a very specific, highly mysterious remnant. It's literally the birth of something entirely new. The outer layers of the star get blasted away into the cosmos in a massive supernova. But the core, that dense, heavy heart of the star, it completely implodes.
So the crucial point is that a neutron star is an extraordinarily dense cosmic object left behind following that stellar collapse. Basically, it's the core of a dead star, squeezed and crushed down by its own immense gravity into something almost incomprehensible. The pressure is so intense that protons and electrons are violently smashed together until they actually merge into neutrons. And that is exactly what we're left with, an entire stellar core made almost entirely of densely packed neutrons, locked in a tiny sphere just a few miles across.
Section 2. The billion-ton teaspoon.
And this brilliantly illustrates exactly what we mean when we use the word dense. I want you to picture holding an ordinary, everyday teaspoon right there in your hand, the exact same kind you'd use to stir your morning coffee. Now, imagine scooping up a teaspoon filled not with sugar or coffee, but with a newly formed material carved straight out of a neutron star. Try to picture that tiny volume of dark, super compressed matter sitting right there in the bowl of your spoon.
If you are holding that single teaspoon of neutron star material, well, it would weigh around 1 billion tons right here on Earth. Just let that sink in for a second. 1 billion tons. Sitting right there in the palm of your hand. Think about the combined weight of every car, every skyscraper, every mountain you have ever seen, compressed down into a space no larger than a single sugar cube. At this level of density, standard physics starts to sound an awful lot like absolute science fiction.
Let's move to Section 3 and see how this builds. Extreme spin and crushing gravity.
Now, what's really interesting here is how these dead stars behave dynamically. We already know they're impossibly dense, but they also spin incredibly fast. And we aren't talking about a slow, lazy rotation. We're talking about a massive, ultra-dense remnant rotating hundreds of times every single second. Imagine an object heavier than our own sun spinning around completely several hundred times before you can even blink. And because all that mass is packed so tightly, they generate a surface gravity roughly 2 billion times stronger than Earth's. 2 billion times. Think purely about that surface gravity for just a moment, a force 2 billion times stronger than the gravity keeping you sitting in your chair right now. It's a crushing, terrifying gravitational pull way beyond anything we could ever replicate or even fully visualize. If you were to somehow stand on the surface of a neutron star, that gravity would literally instantly compress your body down to the atomic level. It is a one-way ticket into an absolutely unyielding gravitational grip.
It really all comes back to this one defining reality. We're looking at an object so dense that just 1 teaspoon of its material would weigh around 1 billion tons on Earth. This single fact perfectly summarizes the impossible extremes we've explored today. From the explosive collapse to the mind-boggling density, the dizzying spin, and that crushing gravity, the neutron star challenges absolutely everything we think we know about the physical world. It forces us to confront just how intense the universe can really get.
Which leaves us with this final, lingering thought. If a single collapsed star can create such unbelievable extremes of density, spin, and gravity, well, what other incomprehensible forces are hiding out there in the dark of our universe? Thank you for joining me for this explainer. Keep wondering, keep exploring, and I'll catch you in the next one.